Hello everyone. Okay, now this is section 6.1. So this section, I will be dividing this section into two parts or two lectures. So today I'll be doing a few examples, and on the next lecture. So basically, this lecture is Tuesday lecture. All right, because Monday was the exam day. So this is Tuesday lecture, and also the Wednesday lecture, I'll be covering the same section, 6.1. Well, if you see the schedule, on Wednesday, actually I'm supposed to cover 6.2, but I will skip this section 6.2. So instead of 6.2, I'll be covering 6.1. Okay, so I'm not going to cover section 6.2. Let me check it one more time. Yes, section 6.2. So Thursday I'll cover section 6.3, and Friday I'll cover section 6.4. All right, so I'm not covering this section 6.2. I'm just going to skip this section. All right, instead of this section on Wednesday, I'll still cover 6.1. Okay, now then this lecture. Okay, so this lecture is about area between curves. So before I start this section, well, if I review the thing that I did last week. Okay, so this is, let's say, f of x function, and if I want to find the area between A to B, then, well, we know that well, this is x-axis. So with x-axis, everything above x-axis, well, it's going to be positive area, and everything below x-axis is going to be negative area, right? So yeah, we learned this last week. All right, now let's say there is, well, two functions. Let's say the first one is f of x, and the second one is g of x. All right, so both of these functions are a continuous function, right? A continuous function. And let's say we have an interval a to b. Okay. So now I need to find the area that is enclosed by these two functions. So I can say, well, it's going to be this reason, right? The area enclosed by these two function f of x and g of x within this interval is going to be this area, right? Now I need to find the area, or I need to find this area. Okay, so to find this area, or area between these two function, or let me just say area A, is from A to B, and first one I have to take the area of f of x dx, which will give this whole area, right? And now subtract this whole area by this area. So that will be, again, from A to B, g of x dx, right? So the whole thing minus this thing will give this area between these two interval A to B. Okay, now this one also, well, since this one has same interval, so I can again combine this to a single integral from A to B, f of x minus g of x dx. Okay, and also, well, let's say we have a graph something like this. This is A, This is B. Okay, now here I want to find the area, well, this area, okay, which is from A to B. So in this area, let's say if this is f of x function, then like I said before, anything below x-axis will be a negative, right? So to consider this negative, I need to consider here a negative f of x dx. So the area will be negatives because I'm considering negative reason, right? So then this reason is negative, this reason is positive. Okay, so just remember these things. Now, now let's start a problem. Okay, so now I have to find the area bounded by this graph and y is equals to 0. So okay, what is y is equals to 0 graph? What is y is equals to 0 graph? Y is equals to 0 is actually x-axis. Okay, instead of saying x-axis, we can even say y is equals to 0. So both of these are same thing. The reason for that is if you pick any point on x-axis, y is always 0. Well, x value will be different, but y is always 0. So that's why this line is also called y is equals to 0 line. Okay, so now I need to find the area bounded by this graph and a y-axis between these two intervals from 1 to 4. Okay, so first let's see, we don't need, well, we just have to look at the shape of the graph, or at least we need to find where these graphs are going to intersect at x-axis or maybe y-axis. Okay, so if you go back, let me write it here. So if you go back to chapter 1, well, if we have a quadratic function, well, as we know that this is a quadratic function because we have x squared. So our highest power here is x squared, or 2, right? So the highest power is 2, so that's why we consider this a quadratic function. Okay, so if you have a quadratic function, and if the coefficient of x squared is, if it is a positive, then the shape will be like this, or concave up. If this coefficient is negative, then it will be concave down, something like this. All right, so if we know that fact, then well, here x squared, well, the coefficient is 1 here, right? But since there is a negative number, so it will be a negative 1. So if it is a negative, then the graph will be concave down. Okay, now let's see at least x-axis. Okay, so if we consider x is equals to 0, what is y, or what is f of x? So y or f of x is equals to, if you consider x 0, so this will be 0, this will be 0, y is also 0. So the graph, the function must go through 0, 0, right? So our graph is going to be something like this, which goes from 0 to 0. And what about this point? How do we know this point? Well, again, I can find this point, or x-axis, if I consider this, if I consider y0 or fx0, so 6x minus x squared. So from here, I can factor out x. So 6 minus x. So from here, it's either x is equals to 0, or another one is either 6x minus x is equals to 0. So x is equals to positive 6, right? So this point must be positive 6. Okay, and this point obviously we found Um, so we already found that here also, right? So that's how so first we have to use algebra, okay? So whenever you start this kind of problem, at least know how the graph is going to look like, and also find x-intercept or y-intercept, okay? So now I need to find, like I said, I need to find the area bounded by this graph and this line. So that should be this reason. Okay, so I need to find the area of this reason. Well, no, here it's basically, sorry, it's from 1 to 4. So sorry, this is not the whole thing. It should be from 1 to 4. So 6 is here, so 4 should be somewhere down here. And 0 is here, so 1 should be somewhere down here. So it should be area of this region. So area of this region between this interval, right? Now to get that area, so again I can say the area, or A is equals to integration from A to B, which, well, A is 1, B is 4, so 1 to 4 of this function, f of x function, and dx. So after this, from 1 to 4, f of x is 6x minus x squared dx. Right, so from here, now let's take the integration of this. Well, this is just the number, so the number will stay there. So x is integration is x. Well, there is 1 on the power, so x to the power 1 plus 1, which is just 2. I don't have to write that. I'll just write 2 and over 1 plus 1 again, which is 2. Minus x to the power 2 plus 1 is 3 over 3. Right, and after this, a line something like this from 1 to 4. Now after this, well, first let's take 4, plug this in here. Well, this will go 6 over 2 is just 3. So 3 times 4 square minus, again, 4 to the power 3 over 3. Okay, that's the first one, 4. Minus, and now 3, x is now 1, so 3 times 1 square, this minus 1 to the power 3 over 3. So make sure you distribute this negative to both of this. Okay, so after you do all the calculations, which you can do this on your own, so our answer is going to be 24. All right. Okay, then now next one is this one. Okay, so now we need to find the area bounded by so here, okay, so this is given. So here, well, now the coefficient of x squared is 1, or it's a positive, right? So that means our graph is going to be concave up, right? So, and also again, just like we did here, if, or here, let's find x intercept point. So to find x intercept point, I can assume y0. So 0 is equals to x squared minus 2x. So from here, I get 0 is equals to, I can factor out x, so x minus 2. So from here, either x is equals to 0 or x minus 2 is equals to 0, which is x is equals to positive 2. So that means our x-intercept point will be here at 0 and here at 2. So the graph will intersect at these 2 points and it will be concave up, something like this, right? Okay, anyway, so here now we need to find the area bounded by these two between this interval. So it will be from -1, so this is 2, so that means 1 should be somewhere down here. So I need to find the area, this area, and also this area. Okay, so now now let's find the area is equals to, okay, so now as we said that now this graph is going to be bounded with this x-axis line, right? With x-axis line. So anything below x-axis we'll consider negative in this case, right? So now, so that's why we are going to get, so this is 0. So that's why here we have to consider two integral. So first one will be from -1 to 0. So from -1 to 0 of f of x dx, right? Plus another one will be from 0 to 1. And the reason I'm considering two integrals is now, since this is in the negative region, right? So like I said here, if you're considering anything below x-axis, then we take negative, right? So that's why here I'm going to say negative f of x dx. Okay, so here I can bring this negative out here. F of x is x squared minus 2x dx minus 0 to 1 f of x, sorry, f of x is x squared minus 2x dx. Okay, so now since these two has two different integral or two different intervals, this is from negative 1 to 0, and this is from 0 to 1. So I cannot combine here right now. So now let's just take the integral of this separately. So this one is, if I take the integral of this, x squared will be x to the power 3, x to the power 2 plus 1 is 3 over 3, minus 2 times x is x squared over 2, right? And now here this will be from -1 to 0. Minus. Now again, on this one, it will be x to the power 3 over 3 minus 2 times x squared over 2. And again, this will be now from 0 to 1. Okay. Now, now we have to substitute this 0 to these, right? So here, if it is 0, then 0 divided by 3 is 0, minus, again, this is 0, so 0 divided by number will be 0, so that will be gone, so we don't have to consider. Minus, right, 0, minus, again, now negative, so -1 to the power 3 over 3, minus 2 times -1 square over 2, right? So we're done with now this part. Minus, we still have this, so we have to make sure we have to distribute this to both of this, so we'll do that later. Let's just put a big bracket. So now first let's consider 1. So if it is 1, then 1 to the power 3 over 3 minus 2 times 1 square is still 1, so 2 over 2. It's just 1. right? And minus now 0, so 0 will be this will be 0, this will be 0, so we don't have to even consider that part. So it's just that we will get this. Okay, and after that, I forgot one thing here. So minus, right? So minus here, this also has to be distributed. This minus should be distributed to both of this. All right, so they are, well, you guys can make small mistakes here, just like I did here. So if you forget to distribute this negative to these two, then you'll get a different answer. So just be careful with sign, all right? You can easily make mistakes on these things. So just go slow, be really careful, all right? And then after you put this in a calculator, or if you do a few algebra, then your final answer is going to be 2. Okay, now the third one. Okay, now here we need to find the area bounded by the graph. Now we have 2 graphs. Okay, so whenever we have 2 graphs, well, you can just apply this this idea. So now here we need to consider which one is going to be on the top and which one is going to be on the bottom. So it has to be always top minus bottom. Okay, so now to consider that part, you have to actually make a graph. So I guess you all know how to make a graph at this point. So now to get a graph, it's just that you have to make a XY table for at least for this linear equation. So give some value for X, you'll get Y. So basically you'll get a line, something like this. Okay. Which will be f of x is equals to 1 over 2x plus 3 line. Good, this line. And again, you can do the same thing, XY table for this one. And also we have a negative. So that means our graph is going to be concave down. And in this case, this g of x will be on the bottom. Okay, and you can also find this, it should be a little bit different. Let me just do it here. So if I consider this a vertex, well, I can find the vertex of this equation because I need to know whether this graph is going to be above this line or below this line. So for that reason, I need to find at least vertex, and also I need to find the x-intercept point. So the vertex, I can find the vertex by using b minus, sorry, negative b over 2a, which is h, and k is, well, whatever value you get from here, plug in that value to this g of x, so g of h. Right, so I did this in chapter 1, so please please review that, okay, if you're still confused with that. But anyway, so f of x will be on the top in this case, and g of x will be on the bottom. And now we are also considering the interval is from -2 and 1. So -2, let's say it's somewhere down here. So let's say this is -2, and 1 is, let's say, somewhere down here. Okay, and you will get something like this. So now I need to consider the area bounded by all of these. So area bounded by this, and x is equals to -2 line is x is equals to -2 line is this line, a vertical line, and x is equals to +1 is this vertical line. So now we need to consider the area. We need to find the area of this region. Okay, so area enclosed by these 2 graphs. So like I said here, whenever we have a two graph and we need to find the area of this middle region, you just have to apply this f of x minus g of x of that whatever interval we have. Okay, so that means in our case, the interval will be from -2 to +1. So -2 to +1 of f of x, right? On the top we have f of x. On the bottom we have g of x. So f of x minus g of x dx. Okay. Now, so f of x is 1/2 x plus 3 minus g of x is, so I have to distribute this minus to both of this. So it will be minus x squared will be positive x squared minus plus 1 is -1 dx. All right, and now I can, well, I can see that 3, we have 3 and -1, so 3 minus 1, I can also write this plus 2. Right, now after this, now I can take the integration of, this. So a number, I can just bring that out, just take the integration of x, which will be x squared over 2. The integration of a number will be whatever number is there times x, right? And for this one, it will be x to the power 3 over 3. And this is from -2 to 1. Okay, so now just like I did before, plug this in first to x minus. All right, so plug this one here, you get something minus, and make sure you have to distribute this minus to whatever number you will get after that. So minus, now after that, plug this in and write that down here, and your final answer will be in this case, you'll get 33/4, which is also 8.25. Okay, so here you have to spend a little time. So once you get a graph, it's just taking the integration, right? So you have to spend a little bit time considering or making the graph, or at least know, in this case, at least know which one is going to be on the top and which one is going to be on the bottom. Okay, so for that, you have to make a graph using XY table, and for quadratic function, at least find the vertex using this formula. All right. Okay, so that's it for this lecture. Again, like I said before, I will continue this section in the next video as well. So I still have 2 more examples to do. So I'll do that in the next video. And like I said, I'm going to skip 6.2. Okay, so I'm not going to cover 6.2. All right, so thank you, and I'll see you on the next video.